Casio, quadratic equations, completing the squares.
Hello Casio Nation! Welcome back to our Casio Tech Talk video. And today we will discuss a grade 9 topic which involves a quadratic equation and solving for its roots using completing the square. Now we have here two quadratic equations to solve for their roots. So let's try and solve for the first one. So we have x squared minus 12x minus 9 is equal to 0. So the first thing that we need to do in performing completing the square is to transpose all constant to the right side of the equation. So if this is negative and we transpose that, we just simply add 9 to both sides of the equation. And then we have here x squared minus 12x is equal to positive 9. Then we need to perform completing the square. So how do we do that? Take note of the expression and the coefficient of the middle term. So we have here negative 12x. So take note of the coefficient and that will be negative 12. So what we need to do is to divide that negative 12 by 2, which is negative 6. And then we need to take the square of that negative 6 and we will add that, which is 36, and add that to both left and right side of the equation, which will give us x squared minus 12x plus 36, and in the right side of the equation, we need to add 36 also to positive 9. Now, we simplify. We have 9 plus 36 is equal to 45. And then here we have a perfect square trinomial and we need to express that as a square of binomial. But how? We just need to simply get the square root of the first term and the last term. So that will be square root of x squared is x and the square root of last term is 6. And what we need to do is to copy the middle term sign, which is negative. So that will be x minus 6, and we need to raise that to the second power. Next, what we need to do is to simply get the square root of both sides of the equation to solve for the value of x. So we need to get the square root of both sides. So the left side of the equation will now be x minus 6. And square root of 45, since 45 is not a perfect square, we need to express that into something that can be extracted as a perfect square. And we know that 45 is simply 9 times 5. So we can express this as a product of square root of 9 multiplied by square root of 5. And we know that square root of 9 is positive 3, positive or negative 3. So we have this one, positive or negative 3 multiplied by the square root of 5. And the left side of the equation will remain as x minus 6. And then we need to move or transpose the negative 6 to the right side. And then we need again to add 6 to both sides of the equation. And that will be our x is equal to 6 plus or minus 3 is square root of 5. And now we have here the root of our quadratic equation x squared minus 12x minus 9 is equal to 0. Now let's check if our roots to our first example is correct. So what we need to do is to access the function equation by pressing this button, the mode setup button, and go to equation or just simply type 5. And then you can observe that there are a lot of different polynomials here, and what we need to do is to access number 3, which indicates a quadratic equation. So press 3 here and then type in all the values of the coefficient of our given example. So in this case, we have x squared minus 12x minus 9. So therefore, our value of a is 1. The value of b is negative 12. And the value of c is negative 9. So that will our coefficient and then we press equal sign to find that the value of the first root is 6 plus 3 square root of 5, and then the second root is 6 minus 3 square root of 5, which in line with our answer, x is equal to 6 plus or minus 3 square root of 5. Now let's move on to our second example. We have here 3x squared minus 12x plus 7. So what we need to do is to first transpose by now we have positive 7. We need to subtract 7 to both sides of the equation. So that will become 3x squared minus 12x is equal to negative 7. And then we need first to perform factoring using the common monomial factor. So we need to factor out the 3. So we need to divide both terms by 3. So we need to divide this by 3 and this one 3, and then we have 3 multiplied by x squared minus 4x. Put a space, then negative 7. Then we need to divide both sides by 3. And then we cancel this out. Then we have x squared minus 4x is equal to negative 7 over 3. Now we need to perform completing the square. We divide this by 2. So we have negative 2. And then we square that to get positive 4, which we need to add to both sides of the equation. Okay? Now, we need to get the square of binomial of this perfect square trinomial, which a while ago we did. Square of the first term, square of the last term, and copy the middle term sign. So we have here x, copy the middle term sign, square root of 4 is 2. Then, square. Then we simplify this, negative 7 over 3 plus 4 is simply negative 7. 3 times 4 is positive 12 over 3. And negative 7 plus 12 is simply 5 over 3. And what we need to do is we need to extract the root of x minus 2 squared is x minus 2. But take note, this is a radical expression of both numerator and denominator. So we need to perform rationalization to both numerator and denominator. So for us to rationalize, we need to remove the root sign of the denominator. So to do that, we need to multiply both numerator and denominator by square root of 3, so that we will have in the numerator is square root of 15, then square root of 3 over times square root of 3, square root of 9, and square root of 9 is positive 3. So that will be our right side of the equation. So I have positive or negative is square root of 15 over 3. And then with last one, we need to transpose our negative 2 to the right side of the equation, meaning we need to add 2 to both sides of the equation. And then we have x is equal to 2 plus or minus the square root of 15 over 3. Now, if we add this into a single term, so we need to multiply 3 times 2, which is 6, plus or minus the square root of 15 all over 3. So therefore, our root is 6 plus or minus square root of 15 over 3. Now let's check if the root of our second example, 3x squared minus 12x plus 7 is equal to 0, is really equal to 6 plus or minus square root of 15 over 3 using our calculator 570 ES plus. Now, same thing as we did in our first example, we need to access the mode 5 or the equation mode and the quadratic equation. Then we type in each values of our coefficients a, b, and c. So in our case, a is equal to 3, then b is equal to negative 12, and c is equal to positive 7. Now we have entered all the values of a, b, and c. We can now go and press equal sign to find that the first root is 6 plus square root of 15 over 3, and the second root is 6 minus square root of 15 over 3, which in line and the same as our answer using manual computation, which is x is equal to 6 plus or minus square root of 15 over 3.